Rambutan hits a modern factory as a shelf life emergency because the fruit is high in sugar, high in moisture, and its thin skin bruises easily. So quality can collapse in days if temperature and handling aren't controlled. The entire line is engineered to do three things fast: remove field contamination, stabilize color and texture, and pack a consistent edible portion that survives export without turning brown, mushy, or fermented. The first control point is receiving, where fruit arrives in vented crates or bulk bins and is immediately lot-coded by farm, harvest time, and variety. Rambutan maturity is not judged by looks alone, because red skin color can be misleading. So plants often run quick brick sampling on pulp and track fruit temperature on arrival. A few degrees too warm accelerates enzymatic activity and yeast growth. So the intake area is designed like a chilled logistics hub, not a produce market. Gentle unloading is critical because rambutan bruises under its own weight. Many factories use water flumes instead of dry belts, letting fruit float and move with controlled flow rather than dropping onto hard conveyors. Flume channels are engineered with screens, rock traps, and low shear pumps because stones, stems, and sand are common. And one piece of grit can damage peelers, cutters, and sealing surfaces downstream. Washing is staged, because a single rinse can't handle sticky latex residues, field dust, and microbes at the same time. Rotary drum washers and brush beds scrub the spiny skin, while overhead spray bars apply a metered sanitizer. Commonly peracetic acid or another approved system, controlled by pH and ORP sensors. Countercurrent water flow is used so the cleanest water touches the cleanest fruit, reducing consumption and lowering the microbial load entering cutting and peeling zones. After washing, high-speed grading turns a mixed harvest into predictable processing feed. Roller graders separate by size so peeling and coring machines can run at fixed settings instead of constantly jamming. Machine vision cameras check color, surface defects, split skins, mold spots, and insect damage. Then air jets or diverter gates eject off-grade fruit in milliseconds. This step protects the entire run, because one moldy crate doesn't just lower yield, it can seed spores across wet equipment and become a sanitation problem that steals hours of downtime from here. The process splits based on product type. The two largest industrial pathways are canned rambutan and syrup, and frozen rambutan, pulp or arils for desserts and beverage manufacturing. Both require the same first transformation. Separate the edible REL from the skin and seed while minimizing damage and browning. Peeling is the toughest. Mechanical task because rambutan skin is leathery and the REL is slippery and delicate. Traditional processing relies heavily on manual peeling. But modern high-throughput factories use semi-automated systems inspired by lychee lines. The fruit is indexed into pockets. Then a scoring ring or blade makes a controlled cut around the shell, shallow enough to avoid cutting into the aerial. Rubberized rollers apply compression to pop the shell open along the score line, and the aerial is released with minimal tearing. The machine settings depend on fruit diameter and skin thickness, which is why upstream sizing is so important. Once the aerial is exposed, the seed becomes the next problem. Rambutan seeds cling, and tearing the flesh creates ragged surfaces that brown quickly and leak juice into syrup. Mechanical pitting systems use a coring tube or push-pin geometry to separate seed from flesh. But the pin must align with the seed axis to avoid ripping the aerial. That's why some lines use orientation channels and vision-guided positioning, because better alignment directly increases intact aerial yield. An intact yield is what sells in premium cans. Immediately after peeling and pitting, the factory has to block enzymatic browning and stabilize texture. Rambutan arils oxidize when cut surfaces meet oxygen, and the browning is accelerated by warm temperatures and metal contamination. So the arils drop straight into anti-browning dips, typically citric and ascorbic acid solutions, where concentration and contact time are controlled like a chemical process. For firmer bite, calcium salts, such as calcium chloride, can be added to strengthen pectin networks and reduce softening during heat processing. But the dosing must be tuned to avoid a bitter or overly crisp texture at this point. The plant runs an intensive inspection loop because the product is now high value per kilogram. Operators and cameras look for seed fragments, torn arils, and remaining peel pieces. Seed fragments are not just a consumer complaint. They can trigger recalls and retailer penalties, so metal detection isn't enough. Many modern lines use optical sorting and density separation. Because peel and seed have different reflectance and density compared to clean aerial tissue. For canned rambutan, the next engineering system is syrup preparation, and it runs like a beverage plant. Large stainless tanks blend water and sugar to a target Brix, and the syrup may include acid adjustment to hit a safe and stable pH profile. Inline refractometers verify sugar concentration continuously, because syrup Brix affects sweetness, heat transfer, and net drained weight compliance. Syrup is filtered to protect valves and fill nozzles, then heated so it fills hot, improving exhaust performance and reducing dissolved oxygen, can and jar. Handling is fully automated in a modern facility because glass and metal packaging require stable flow and precise alignment. Containers are depalletized, rinsed with filtered air or water. It carried into star wheels that index each container under the filler. Fillers portioned aerials by weight or count while controlling drop height to avoid bruising. Liquid fillers then add syrup to a target headspace because headspace volume determines vacuum formation and thermal processing behavior. Before closing, the line removes trapped air because oxygen drives flavor fade and browning even in syrup packs. Exhausting systems use steam flow or vacuum channels to displace air from the headspace. Then, seamers for cans or cappers for jars close the package under controlled torque or seam geometry. Seam integrity is a true mechanical specification. A small seam defect becomes a leak, and a leak becomes spoilage. Thermal processing is where shelf stability is manufactured. Canned rambutan is typically processed in retorts, pressurized vessels that heat sealed containers to a validated time and temperature. The goal is commercial sterility without destroying texture. So retort, recipes are tuned for product size, syrup Brix, and container type. Overprocessing turns aerials translucent and mushy. Underpressing risks spoilage and safety failures. Modern retorts log temperature and pressure curves digitally, and any deviation automatically triggers product holds. Because validation is only valid when the recipe is actually followed. Asterisk. Cooling is controlled to prevent container shock and product damage. Retorts cool in stages, often using controlled water sprays, because a rapid temperature change can crack glass or distort lids. Cooling water quality matters too, since post-process contamination can occur if cooling water is dirty and seals are weak. So plants treat and monitor cooling water as part of the safety system. Once cooled, containers go through inspection. Vacuum checks confirm proper seal and headspace performance. Checkweighers verify net weight and drained weight targets. Vision systems confirm lid presence, seam quality markers, and readable lot codes. Labeling and case packing are integrated with traceability so every case can be tied back to the fruit lot. Dip parameters, syrup batch, and retort chart. For frozen rambutan, the stabilization strategy changes. Instead of depending on heat and syrup, the factory depends on rapid freezing and oxygen control. After peeling, pitting, and dipping, aerials are duetted to remove excess dip solution, then spread into a single layer on vibrating conveyors. Individual quick freezing, or IQF. Uses cold air at very low temperatures, moving at high velocity, so each arrow freezes quickly without clumping. Fast freezing forms smaller ice crystals, which protects texture when the product is thawed for desserts or beverage bases. Frozen lines. It's also used glazing or sugar pack methods depending on the target market. A thin glaze of ice can protect against freezer burn, while sugar packs create a protective syrup that reduces texture damage in storage. Packaging is designed for low oxygen and moisture transfer. In many plants, nitrogen flush bags to reduce oxidative flavor changes, especially for long export routes. Asterisk, some factories convert lower grade arils into puree or juice concentrate for industrial customers. That line begins with pulping, where paddle finishers push fruit through screens that remove fiber and any remaining seed fragments. Deaeration under vacuum removes oxygen to protect aroma and reduce browning. Pasteurization then uses plate heat exchangers for short-time heating and rapid cooling, minimizing cooked flavors. Aseptic filling into bags or drums allows ambient shipping without freezing, but it demands sterile valves, sterile air, and strict environmental control around the filler, across all product types. Sanitation is engineered because fruit plants fight sugar films that feed microbes. Clean-in-place systems circulate caustic and sanitizer through pipes, tanks, and fillers at controlled flow velocities to remove residues. Open equipment like conveyors and peelers is foamed, rinsed, and sanitized, then verified with ATP testing and microbiological swabs. The factory's uptime depends on this, because if yeast and mold establish in wet zones, product quality drifts fast and shutdowns become longer. Water and wastewater are major engineering challenges in Rambutan processing because washing, fluming, and dipping generate high organic loads. Wastewater typically has high BOD from sugars and fruit solids, so plants use screening dissolved air flotation to remove suspended organics, and biological treatment to meet discharge limits. Solid byproduct skins and seeds are handled continuously to prevent pests and odors. Some facilities valorize them into compost, animal feed components, or extraction streams for polyphenols and oils. But even when they're just waste, moving them efficiently keeps the line hygienic. Quality control is constant because Rambutan is naturally variable. Brix and pH are tracked to keep flavor stable and to meet acidified food requirements where applicable. Texture is measured with compression tests so the plant can quantify bite and correlate it to calcium dosing and retort severity. Color is monitored because browning is a leading consumer rejection reason, and the plant uses those color trends to tune dip concentration, oxygen management, and thermal profiles. Foreign matter control is layered because wet fruit processing is mechanically intense. Magnets and metal detectors catch ferrous contamination. Ray systems detect dense fragments that metal detection can miss, especially when product is in metal cans. Optical inspection catches peel specks and seed pieces. Each system covers a different risk, and together, they allow high-speed production without relying on slow manual checks. The modern high-tech part of Rambutan processing is not a single flashy machine. It's the way the entire factory compresses a fragile tropical fruit into a standardized export product. Sorting creates uniform feedstock for peelers and pitters. Dips and oxygen control preserve color and flavor. Syrup systems stabilize taste and heat transfer. Retorts deliver validated shelf stability while protecting texture. IQF and aseptic lines create alternative products that match global logistics. And every parameter is log temperature, Brix, pH, residence time. Seal integrity because the only way to ship Rambutan across oceans and still deliver a clean, sweet bite is to treat fruit processing like precision manufacturing.